Friends, we'll study scheduling, the first come first serve algorithm in operating systems. Before we start how to solve the problems using the first come first serve scheduling process, let's see what is scheduling. CPU scheduling is a process which allows one process to use the CPU while the execution of another process is on hold due to unavailability of any resources like input, output, etc., thereby making full use of the CPU. CPU scheduling is done to make the system efficient, fast and fair. Now there are few CPU scheduling criteria that we need to study. The first one is CPU utilization. To make out the best use of CPU and not to waste any CPU cycles. There are CPU cycles and IO cycles which needs to be utilized through the best. Throughput. It is the total number of processes completed per unit time, or rather say total amount of work done in a unit time. These are few criteria which we need to study. The next one is a turnaround time, which is very important. It is the amount of time taken to execute a particular process. That is the interval from time of submission of process to the time of completion of the process. That is the time it got initiated or submitted to work on. And waiting time. The sum of the periods spent waiting in the ready queue, amount of time a process has been waiting in the ready queue to acquire, get control on the CPU. That is, my process is ready, but when the other process is running, my current process has to wait for some time. So that is known as a waiting time. We will see how we calculate the turnaround time and the waiting time. The next criteria is the load average. It is the average number of processes residing in the ready queue waiting for their turn to get into the CPU. That is, we have to calculate how much time it is residing in the waiting queue. Response time. Amount of time it takes from when a request was submitted until the first response is produced. It is the time till the first response and not the completion of processes executed. These are the few scheduling criteria. Now let's see what are the scheduling algorithms. The first one is first come first serve, commonly known as FCFS scheduling. The next one is the shortest job first, commonly known as SJF scheduling, priority scheduling, round robin scheduling and multi-level queue scheduling. In this particular video, we will study and try to solve problems using the first come first serve scheduling, commonly known as FCFS. Let's see what is an FCFS scheduling. It is a very simple scheduling algorithm, the basic. It is a FIFO queue. Why it is known as a FIFO queue? FIFO stands for first in first out queue. That is, as it is first come first serve, so the process which comes first will be executed first, not considering any turnaround time or any waiting time. It is just a basic implementation, but we also consider the arrival time to solve the higher level of problems. Jobs are executed on the first come first serve basis. Easy to understand and implement as it is the basic implementation of scheduling. Poor in performance as average wait time is very high. Processes execute based on their order of arrivals and it causes a convoy effect. Now what is a convoy effect is when the burst time of the first process is very high, the other processes have to wait for a longer time. So that is known as a convoy effect on the processes. Now let's see by solving a problem. Find the average waiting time for the processes which are given. We have process P1 with a burst time of 21. We have process P2 with a burst time of 3, process P3 with a burst time of 6 and process P4 with a burst time of 2. we have said something called a convoy effect. We say when the burst time of any particular process is very high, it leads to the convoy effect. This is how the effect comes into picture. Now the first thing that we need to do to find the average waiting time is we need to draw its Gantt chart. And when we draw its Gantt chart, we will have to calculate its average waiting time. Now the Gantt chart is drawn like this. As we have 4 processes, we draw a single row table, we can say, and we put the processes as P1, P2, P3 and P4. Now the starting time for P1 is 0. So the waiting time, there's no waiting time, it initiates from 0 and it's completed in 21 milliseconds we take. So process P1 takes 0 to 21. So where there's no waiting time, it starts at 0, but for process P2, the waiting time is 21 as it starts after 21. Now P2 executes for 3 milliseconds. So when we say 21 plus 3, that leads to 24. So 0 plus 21 plus 24. So my process P3 starts at 24 milliseconds and its burst time is 6. So 24 plus 6 makes it 30. So it is 30 over here. So the total waiting time for my process P4 to start is 30. So we have to find out the waiting time as 0 plus 21 plus 24 plus 30 divided by 4. It leads to 18.75 milliseconds. And all the processes combined together get executed at 32 milliseconds. That is, at 30 milliseconds process P4 started and its burst time is 2. So total completion takes 32 milliseconds. This is how my average waiting time is calculated when I have only been given the processes and its burst time. There are no arrival times given in this particular problem. So this is the simple first come first serve scheduling. As the processes are coming, we see with the burst time and we calculate its waiting time and we draw its Gantt chart. Now let's take another example where we have been given the arrival time of the processes and the burst times for the processes. Find the average waiting time and average turnaround time using the FCFS algorithm. Now let's start. For these processes, depending on the burst time, we calculate the average waiting time. But first we draw the Gantt chart. Process P1 arrives at 0. It executes for 6 milliseconds. That's the burst time which is given. So it is 6 over here. At 6, process P2 starts and it runs for 1 millisecond. So it is 6 plus 1, 7 milliseconds. And process P3 starts at 4. So 7 runs for 4 milliseconds. So 7 for 4 make it 11. And at 11 my process P4 starts. So 11 plus 3 is 14. So total time this particular 4 processes run for is 14 milliseconds. And the average waiting time without considering the arrival time is 0 plus 6 plus 7 plus 11 divided by 4 is equal to 24 by 4 is equal to 6 milliseconds. So this is the average waiting time by considering only the burst time and not calculating or not considering the arrival time. Now let's see how we solve this problem by considering the arrival time. Now we have the arrival time over here, we have the burst time. We have to first find out what is the completion time, and the completion time can be considered from the Gantt chart. It is 6 for process P1. 6 plus 1 makes it 7. So completion time for process P2 is 7 milliseconds. 7 plus 4, that is we add these two and we get 11 over here. So this is the completion time for process P3, and 11 plus 3 makes it 14. So this is the completion time for process P4. Now let's see what is an average turnaround time. How do we calculate the turnaround time? You see I've highlighted two portions. The two rows with two columns which are considered over here is to calculate the turnaround time. Now turnaround time is calculated as completion time minus the arrival time. So For my turnaround time, first I need to calculate the completion time. So this is how we've calculated the completion time. So turnaround time is completion time for the first process. The completion time is 6 and the arrival time is 0. So the turnaround time for process P1 is 6. Turnaround time for process P2, the completion time is 7, which is taken from here, and the arrival time is 2. So 7 minus 2 is equal to 5. So turnaround time is 5. And for process P3, completion time is 11 and arrival time is 4. So 11 minus 4 is 7. And for process P4, the completion time is 14 and the arrival time is 5. So the turnaround time is 9. Now, to find out the average turnaround time, we need to add all of them divided by 4. So we get the average turnaround time is 6.75 milliseconds. So after calculating the turnaround time, let's see how we calculate the average time. Now waiting time is calculated by considering turnaround time minus the burst time. So turnaround time for process P1 is 6 and the burst time given is 6. So 6 minus 6 is 0 is the waiting time for my process P1. The turnaround time for process P2 is 5 and the burst time is 1. So it is 5 minus 1 is 4. And turnaround time for process P3 is 7 and burst time is 4. So it is 7 minus 4 leads to 3. And the waiting time for process P4, turnaround time is 9 minus the burst time is 3. So 9 minus 3 is 6. So waiting time for these processes by using the arrival time is listed over here, and we calculate the average waiting time is equal to 0 plus 4 plus 3 plus 6 divided by 4 is equal to 3.25 milliseconds. So you see how the waiting time, average waiting time has changed when we have considered only the burst time and now considering the arrival time. This is how we calculate the average turnaround time and the waiting time using the first come first serve scheduling algorithm. Thank you.